Okay, so if we say that, let's say 1, 5 is an interval about the mean, mu, mean, what do we really mean is that this interval is symmetric about the mean. What does that mean? What does it mean that this is symmetric about the mean? Okay, it means that, so if I have this interval between 1 and 5, the mean is not here. The mean is not here. The mean is exactly in the middle. So that's what we mean by a symmetric interval. Symmetric interval. Better, so it's clear. Symmetric interval about the mean. It means that the mean is right in the middle. So if I give it the interval 1, 5, how do I find the mean of this? Well, I add 5 to 1 and I divide by 2. So 5 plus 1 divided by 2 is 6 divided by 2, which is 3. So 3 is right in the middle. So please remember this. If we are given the interval and we are asked to find the mean, all we have to do is add these two and divide by 2, and we get exactly 3. So what is now the error? It's called margin of error. Is the distance between 1 and 3 or the distance between 3 and 5? It doesn't matter. So you either subtract from 3 this end of the interval, which is 1, or you subtract from 5 the mean, and you get the same answer. So this has to be 2 units in both cases. Because we are going to encounter problems, they are going to try to trick us with this. So one more time, if I'm given the interval to determine the middle, if I'm told that is an interval about the mean, it means that the mean is right in the middle. What do? 1 plus 5, add, divide by 2. If I'm asked to find the margin of error, it doesn't matter how I find it. 3 minus 1 or 5 minus 3. Same thing. Now, when we're asked, let's say, find 90% confidence interval for the mean, I have to start with the point estimator and add and subtract the margin of error. So I have to start with the point estimator. If I don't have the point estimator, I cannot determine a confidence interval now of any level you want. So I have to have the point estimator. So once I have the point estimator, this will be the confidence interval. This is denoted by E. Okay, so how will the confidence interval look like? X bar minus E, X bar minus E, this will be the 1 that I'm talking about in my example, and the X bar plus E, which will be this. Okay, now, how do I determine the margin of error? That's the question next. In order to construct the interval, I need to determine the margin of error. Stop me anytime if you have any questions. I'll go over this many times with examples too. How do we determine the margin of error for mean? So the margin of error is, it depends on the confidence interval, the level of the confidence. If this is 90, I'll get a margin of error. If this is 89, I'll get a different one. If it's 95, I'll get a different one, and so on and so forth. So this E is calculated with that Z alpha over 2 that I showed you. StatCrunch calculates it differently than the book because they came up with some tables showing just the positive side, not the negative side. It's okay. And now here we have S over the square root of n. So this is the margin of error for the mean. And this has to be put in here in order to determine the confidence interval. I have to have the sample, standard deviation. I have to have the sample size. And now what happens here is, because we have the sample standard deviation, we will not be using the z. We're going to be using something else, very close, but some other distribution. It's called t distribution for alpha over 2. So why we replace z? Normally it should have been z. But the reason we replace z with another distribution that I will talk about in a minute is because we do not have the sigma. We do not have the standard deviation of the population. We have the standard deviation of the sample. Okay. Now, by comparison, when we are asked to find the confidence interval for the population proportion, so this is for mu. Confidence interval for the population mean is this, where E is T alpha over 2 S over the square root of n. Now, for P, the confidence interval would be the same idea, P minus the margin of error and P hat plus the margin of error. What is P hat? Is the proportion from the sample. What is X bar? The mean of the sample. Again, okay. Of course, E has a different formula because now we are talking about proportions. And that is Z alpha over 2 and the square root, what we had before in sampling distributions, P hat 1 minus P hat divided by N. And here, this is indeed the standard normal. I'll come back to that. Let me talk about this and how we determine it. So if you are telling, give me a confidence level, any confidence level you want to work with. I'm on page 4. Anyone would like to give us a confidence? Okay, I'll choose 90% then. If we want to determine a confidence interval using a confidence level of 90%, I'm going to put here for P, because we're talking about Z distribution. Then, remember we did this before. This is our 90%. And how much is in tails? So the whole thing has to be 10%, so this must be 5%, and this must be 5%. These 2 points are the negative Z alpha over 2, and this point is Z alpha over 2. Do you need to memorize these numbers? There are 3 important numbers, but you don't have to memorize them. How do I determine these? Very easy. With the inv norm. So where is my inv norm? Right here? Here it is. And then we're going to talk about the t distribution. So, but I want to exhaust the proportions first, and then we'll come back to this one. I just want you to see both formulas from the beginning. So inv norm, area to the left, 0.05. Mu, yes, it's a z distribution, 0 and 1. Everyone knows that by now. And the number is negative 1.645. So this is negative 1.645. Of course, by symmetry, this number here is 1.645. This is the number that will go into the calculation of the margin of error. It depends on the confidence level. Now, if you say, I don't want 90%, I want 95%. Okay, I will do the same thing. I don't have to memorize these numbers. Now I have here 95%, and this is 2.5 and 2.5, right? 2.5%, and 2.5%. And I will determine these numbers. Obviously, this is further away. If it's further away, this number has to be to the left of negative 1.645, as we know, and this number has to be to the right of 1.645. So I'm going to share my screen again, and let's determine, same thing, everything the same, but I want to insert a 2 in here because the area is different. And I press enter, and of course, as expected, negative 1.96. This is a very well-known number, negative 1.96 and 1.96. What do I do with this? If I'm asked to find a confidence interval that is 95%, then this number is 1.645. Again, what are we trying to do? We're trying to first estimate the mean. I'm sorry, I want to do this second. First, we want to estimate the population proportion using the sample proportion. So this is the point estimate of P. But then second step is to determine an interval and say, I am such and such 95% confident that this interval contains the true population proportion. So I'm going to write this sentence here for this one. 95% confidence interval means I am 95% confident that this interval contains the true population proportion. Oops. So please don't say that 95% of the intervals contain. No. I am 95% confident that the interval I just determined contains the true population proportion. So we're trying again to estimate something we don't have. And we do it in two ways. One, with a point estimator, and the other one with an interval estimator. So let's see what we understood and what we need to continue talking about this. And where is my book? So we're talking first about proportion, and then we'll go to the mean, and I have to talk about a new distribution, which is t distribution. So this time we want to start with the proportion, only because it's a little bit easier. We don't have to introduce a new distribution yet. Okay, we have 18 questions. Let's start slowly. Okay, so blah, blah, blah is the value of a statistic that estimates the value of a parameter. So this is definitely point estimator. The point estimate, right? So the point estimate is the value of a statistic that estimates the value of a parameter for the population proportion. And the population proportion, let me put it here again. So the population proportion is denoted by p hat. The number of people with dark eyes in the sample divided by the sample size, or the number of people who are taller than 5 feet over the sample size, or the number of people such and such. So it will give us a proportion. So this is the sample proportion. Okay, back. Good. Who would like to read the next one? So please, everyone will contribute, please.
I can read it.
Please do. Thank you.
You're welcome. It says, one question on a survey asked whether people believe in hell. Of the possible responses, 465 answered yes, definitely, and 623 did not respond with yes, definitely. Find the point estimate of the population proportion who would have answered yes, definitely when asked whether they believe in hell.
Excellent. So now we have to be very careful because it says of the possible responses, which we do not have, they are not telling us the sample size. They are saying in this problem that 465 said yes, and 623 said whatever. Find the point estimate of the population proportion who have answered yes, definitely. So I do not have n. They want us to find p hat, which is the number of people who said yes, 465, divided by a sample size, the sample size, but we don't have it. So what is the sample size?
Are we supposed to add the people who
Very
said yes?
good. The sum of 465 plus 623. That's it. This is the sample size. Excellent. So how much did we get?
1,088.
So yes, it is. So this is our population proportion. Forgive me, our sample proportion. 465 over, which is a point estimate of P, the true population proportion. So I'm going to share my screen. I'm going to divide.
I got 0.
I'm ready.
I got 0.
3 decimal places.
Okay. 0.427.
Excellent. Well done. Okay. Now, careful with this because the table is created only for positive values.